Today we are going to study about moles and solution. We can calculate the amount of a substance in moles in a solution if we know the volume and concentration. Many students like to use the following triangle with quantity to aid to memorize the formula initially. So if you look into the triangle, at the top we have the moles, on the left hand side we have the concentration. Unit is mole per decimeter cube, and on the right side we have volume. Unit is decimeter cube. Number of moles in a solution equals to molar concentration into volume of solution in decimeter cube. Also remember, the mass concentration of a solution is measured in grams per cubic decimeter. The molar concentration of a solution is measured in moles per cubic decimeter. Molarity, M, capital M, of a solution is the number of moles of a solute in decimeter cube of a solution. It is used to calculate the volume of solvent or amount of solute. It is the concentration of a substance in solution expressed as the number of moles of solute per decimeter cube of solution. Concentration, that is mole per decimeter cube, equals to moles of solute divided by volume of solution in decimeter cube. Solution. A solution is a mixture formed when a solute dissolved in a solvent. Water is the most common solvent. Sometimes we call water as a universal solvent. The solute can be a solid, liquid, or a gas. If we have a mixture of sugar and water, sugar is solute, solvent is water, and both together forms the solution. Now let's understand solution and concentration with help of example. Example number 1. What is the concentration in mole per decimeter cube of sodium hydroxide if 250 centimeter cube of a solution contains 2 gram of sodium hydroxide? So you will see they are asking us what is the concentration. We have to find out the concentration in mole per decimeter cube of NaOH. So let's solve it. The first thing that we have to do is we have to convert grams to moles. So here we have 2.0 gram of sodium hydroxide. So let's convert it to moles. So 2.0 divided by 40, that is the molar mass of sodium hydroxide. That will be equal to 0.050 mole of sodium hydroxide. So now we have got the moles of sodium hydroxide. The second step is convert centimeter to decimeter. Here we will see that we have got 250 centimeter cube. So here what we have to do is we have to convert centimeter to decimeter. So second step is convert centimeter cube to decimeter cube. So 250 centimeter cube will be equal to 0.25 decimeter cube. I'm sure you all remember how to do it. We have to divide it by 1000. Now step 3, calculate the concentration. So let's write it down. Calculate concentration. Concentration of NaOH. So let's do that. So how many moles were there? 0.050 moles were there. So you can write down in the bracket mole divided by, what's the volume over here? 0.25. That is in decimeter cube. That's very important to convert the units. Otherwise, our answer will go wrong. So it equals to 0.20 mole. We can either write mole per decimeter cube, or we can also write mole decimeter minus 3. So that could also be written. So the answer, final answer, what is the concentration in mole decimeter cube of NaOH? It will be 0.20 mole per decimeter cube. So this is our final answer. I hope you have understood it. And we are always going to use the relationship that we find in the triangle. Therefore, I don't repeat that, but please keep that in your mind. Let's go to example number 2. Here the question is, what is the mass of anhydrous copper 2 sulfate in 55 centimeter of a 0.20 mole per decimeter cube solution of copper 2 sulfate? Now again, the first step in the numerical is change centimeter to decimeter. So here we have 55 centimeter. Now we have to change it to decimeter. So let's do that. 55 divided by 1000. So it will be equal to 0.055 decimeter cube. So this is our first step. Now next is mole equals to MOLE. Mole equals to concentration. We already know this concentration, that is in mole per decimeter cube into volume. So concentration, that is in mole per decimeter cube into volume of solution of solution. Volume of solution will also, it will be in decimeter cube. So remember the unit. So equals to 0.20 into, this is what we have got. So that's the concentration into, we got the volume. We have already converted it. So 0.055. That is already in decimeter cube. That will be equal to 0.011 mole. So now we have the mole. Now step 3. We have to convert it into mass, that is in gram. That is what is being asked. You'll see what is the mass of anhydrous copper sulfate. So that is our final step. So let's do it. So we already know the formula. Mass equals to moles into molar mass. So what is the mass? Sorry, what is the mole? 0.011 into molar mass of copper 2 sulfate. So let's write it down. 63.5 plus 32.1 plus, we can make a bracket, 4 into oxygen is there, so 16.0. Close the bracket. So this will come to finally 1.8 grams. So we have got the final answer. So what is the mass of anhydrous copper 2 sulfate? It is 1.8 gram. So I hope you have understood it. Let's move down to the third question. Now in the third question, how many grams of sodium chloride needs to be dissolved in 0.5 decimeter cube of solution to make a 0.20 mole per decimeter cube solution. So this is a little different type of numerical. Let's do it. So over here, now first of all, we should find out the moles. We have to find out the moles. So in order to find out the moles, let's use it. So mole equals to, what is it? 0.20. So we have the concentration into, we have the volume. Volume is how much? 0.5. Here we don't have to convert the units, already in decimeter cube. So this will be equal to 0.110 mole of, what are we finding out? Mole of sodium chloride. So let's write it down. Mole of sodium chloride, CHLORIDE. Now we got mole of salt. Now here a next step is convert mole to mass. What are we doing? We are converting mole to mass. So if let's remember it, let's write that down. Convert mole to mass. So let's do that. So M equals to small m into m. So mass equals to mole into molar mass. So whose molar mass? First of all, we are finding out the molar mass of NaCl. So we can write down Mr, that is molar mass of NaCl. We can write it in this way. So let's write it down. 23.0, that is for sodium, plus chlorine will be 35.5, equals to, this will be about 58.5. So that is the molar mass. So I hope you understood that. So we can also write down capital M equals to 58.5, and we can write down the unit gram per mole. So there we are. And here mole is equals to how much? We already have it. It is 0.10 mole. So let's write it down. 0.10 mole. We have already found it. So in order to find out mass, let's mass equals to mole 0.10 mole into molar mass. Molar mass is 58.5, and that is gram per mole. That's the unit. And finally we get the answer as 5.85 grams of sodium chloride, CHLORIDE. So this is your final answer. We have found the mass, that is 5.85 gram of sodium chloride. I hope you have understood it. In the next class, we'll study about titration also, this which is based on concentration and solution, and we'll also study about dilution. Students, I hope you have understood it. You're understanding what I'm teaching. If you like it, please like my videos, like my lessons, please subscribe. Thank you.